So we are going to start the second session today. It is our pleasure to welcome Vicky Charisi from University College London, the Institute of Education. So Vicky is, let's say, generally speaking, interested on what is the impact of artificial intelligence in human behavior. And in particular, she has contributed, let's say, widely and largely into child-robot interaction. So she's gonna discuss today some of her contributions and studies, and we are actually very much interested in seeing and understanding your perspective. So thanks for accepting the invitation, and looking forward to the talk.
Thank you very much, Javier, and for the invitation, and thank you all for being here. From yesterday's discussions and from today's discussions, I realized that this is an extremely multidisciplinary audience. So we have people with very technical background, we have psychologists, I have a question before we start. So I understand a little bit more the audience. How many of you have been involved in any possible way in an actual user study with people? Okay, a lot. Good. So I don't have to explain too much of this. So today here I am I'm presenting this work as an affiliated researcher at the UCL Institute of Education. At the same time, for the last 6 years, I work for the European Commission, the Joint Research Center. This is the independent research institute of the European Commission. The European Commission is a policy institution that what we call multilateral. So it is an umbrella, except from the UK and some other countries, an umbrella institution for policy making. And inside the European Commission, there are what we call policy DGs. So policy DGs, Director Generals, come with different functions in the European Commission, and usually they are separated by their content, etc. So, for example, when it comes to artificial intelligence, which is an extremely multidisciplinary topic, and it appears in several sectors, etc., we have several DGs that actually work for to understand artificial intelligence and how this can be implemented in their policies. For example, one of the most famous for artificial intelligence Director General is DG Connect, who are the ones that have developed also, probably you have heard about the AI Act. This is like a framework, a regulatory framework for AI in Europe that will be implemented very soon. And then there are other DGs, like, for example, DG EAC, which is Education and Culture, that tries to understand how they can use and develop artificial intelligence that would be implemented in educational settings. And there they bring their own knowledge and expertise, and they collaborate with other DGs, etc. So you can see that this is like kind of network of different departments, say, in this. And the JRC, the Joint Research Center where I work, is the scientific institution of this, the research institute of this network. And what we do is what we call science for policy. So the usual procedure is that there is a policy need, and then people from other DGs come to the JRC and ask us to do specific research and to produce scientific findings for this specific research. And most of the times, because we are quite small teams, usually we collaborate with external experts, universities, other institutions, etc. I will explain more afterwards. So for my presentation today, I'm going to try to make this connection between research and policy support. So we do the first part of my talk, it will be about user studies, how we do experimental studies at the JSC and in collaboration with other institutions, and then how these results get into policy support. And then sometimes we have also the other way around. So from policy, there are people that develop policies and then they want to evaluate their policies. And then we run studies in order to understand how their policies, if their policies are effective, etc., in certain situations, of course. And to bring it closer to our own, to the spring project and our own topic of this winter school, I would put like experimental robotics. So this is about the science, etc., always in human-robot interaction. And then in my case, I work with child-robot interaction more specifically, and what we are trying to do is to understand how we can have empirical evidence to support these policies or to evaluate these policies. And of course, this is not, this is like a kind of, there are several aspects. So we have heard, I mean, and in the previous session, we had this question about the ethical considerations when we run studies, right? But this is not only this. So what I'm going to talk today is about how we develop responsible AI, and we take into consideration the vision of certain institutions or certain people, etc., values of people, again, societies, etc., existing work, policy, regulations, etc. And then how we bring in people to design together different technologies, but also policies, etc. And how we can make this meaningful for people that actually develop and deploy the technology. So we saw yesterday the robot here, how we can bring in this information to the people that actually develop these robots and novel systems, etc. And then how we can evaluate these developments in certain scenarios. So this is the first part of my research and of my presentation. And this is all about the scientific research. I am going to keep it in a high level. So I'm going to describe three studies here that have a kind of different methodological approaches. So my main research question, and as it was mentioned beforehand, so this is what I'm trying to do with my work, is to understand what is the impact of social robots, and sometimes also beyond robotics. I will bring an example later on children's behavior and development. Of course, I do work with adults also or other populations, but my main focus is this population, children. So we know that children are very keen in play. They are very curious. They try to make meaning of their life through the engagement of their environments. And we know that many children, and when I talk about children, I talk for people up to the age of 18, according to the UNICEF definition. Nowadays, they interact with many tools, AIs in their lives. Some of them, they even don't know about this, etc. And we know that this has an impact on their behavior. And I'm very curious to understand that when we put embodiment also in this. Of course, there is a huge amount of work on the role of embodiment in children's behavior, trust, etc. But this is my main point, to understand what is the role of robots in children's development and in different tasks. So with the first study, I'm going to describe the methodology of an experimental study. So this means that we had a very controlled environment. So it was not like the environments that we saw yesterday, that it was like, or in the previous talk, with robots in the wild. So this is like an experimental study. We tried to control the task, the different behaviors from the robot, etc., in order to understand how certain behaviors impact children's learning. And here we used the Tower of Hanoi. This is well-established cognitive task that many people have used in the past, etc. And what I like with this task is that it has a kind of incremental difficulty. So it comes, and this is not only because the user, I mean children, even if you choose children of a very specific age group, for example, for this study, I had children 5 to 6 years old or 7 years old, but we have large individual differences. So for me, it was very important to have a task that could adapt to the maturity level of the children. And then we used this robot. This is a simple robot currently being developed by the Honda Research Institute in Japan. It is not a commercial product. It is like mainly a research platform. And it has some expressive eyes, and then we used mainly for communication, verbal communication, but also for some expressions that are more inspired by, I would say, animation that mimicking human expressions. So we ran 2 studies. The first study, it was this was Wizard of Oz. So for those that are not familiar with the term, this is a technique that in the field of human-robot interaction we use sometimes when we don't have a fully developed system, but still we want to understand how the system would work with humans. And what we do is we control behind the scenes the system, and we introduce certain behaviors, etc. So this was the case with the first study. It was not an autonomous robot. And then what we wanted to see is with this setting of the Tower of Hanoi, the robot, and one child, how two different behaviors of the robot would affect children's learning and children's task performance, I would say. So the first so many times when we have tasks and collaborative tasks in human-robot interaction, we have an intervention from the robot that does not is not so well defined in terms of timing, right? So I was very much interested in understanding what would be the difference if we have a robot playing together with a child in a turn-taking setting. So together they should solve this problem here, the Tower of Hanoi, but then we would have like one time the child and the robot, etc. For the interaction here, the robot, just to mention that the robot would only propose certain solutions. So it was like verbally, and then the child would perform the task in that physical Tower of Hanoi. And then the other condition was a voluntary interaction. So the child would solve this problem by themselves, the children would solve the problem by themselves, and whenever they wanted help, they would ask the help from the robot. So it was not robot-initiated interaction, but it was like child-initiated interaction. We measured the process and also some temporal elements there. And what we found, what we found, it was like in the second condition where we have the child performing alone the task and asking for help whenever it was in need. In a later evaluation phase where we didn't have the robot in either conditions, the children would perform better. That means that when it comes to children in that age, exploration is really important, and giving them the time to explore without intervening is really important for their learning. Then a follow-up study, it was with 2 children together with the robot, again the same task. And here we were very much interested in the development of trust. So it was also mentioned beforehand by Mark about robots that they fail. So here we had one condition where the robot would make mistakes on purpose, and another condition where the robot would always propose the correct solution. We had in total 84 children, 5 to 8 years old, and we had a turn-taking interaction. I will describe later the experimental design. First, about the control module. So this was totally autonomous, fully autonomous. And we had, the interaction was relatively simple again, because it was like very controlled environment again. And we had these conditions of cognitive reliability and social positioning. So how the social interaction would be, and then the type of the intervention of the robot. Oops. And then in terms of perception model, we had different cameras and microphones in order to understand. So the children would talk to a microphone. So this was a way that the robot would get the input of when each child would talk, but also we would detect the head orientation, etc. The experimental procedure here, it was with multiple sessions. So first we had the preliminary session where we provided them. So it was like a kind of familiarization with the tool, and also we provided a trust belief questionnaire, a validated questionnaire, in order to understand, because we wanted to understand trust. So we wanted to have a kind of baseline per person to see how much they trust anyway, their friends, their teachers, I mean, the people around them. Then we had a baseline session where we had no robot in order to have this baseline on their cognitive maturity in terms of the task performance, specific task performance. Then we had the intervention session where we did the manipulation that I showed you beforehand, and then an evaluation session with the robot there, but with a voluntary interaction. So the children would only ask the robot for help whenever they need it. And we had different kind of measures of task performance, social interaction, planning disparity. So we sometimes the children, we had a kind of dominant children child, for example, in this interaction, etc. We wanted to understand the social interaction, and then, as I mentioned, the help-seeking behavior, again, trust belief questionnaire, and post-intervention interviews. What we found with this study, it was for our first research question about the cognitive, about the task performance, the children that interacted with the robot that would provide the correct solution would perform better. This during the task with the robot, right? So this was something that we expected, because there was no wrong answer. So they had always the help from the robot. In the condition, when we had the robot that wouldn't provide the correct solution, we observed that we had more child-child interaction, negotiations, because the children most of the times would understand that the robot would make a mistake. In that case, they would negotiate with themselves, between themselves, and in that case, we analyzed their dialogues, and we saw that in this way, they developed a lot of metacognitive dialogue, so they would reason their choices, etc., which was very interesting for us. But what was even more interesting, it was that for this team of people, of children, where they would know that the robot would make a mistake, in the evaluation phase, they still would ask the robot for their help when in need, which is a very interesting finding. So with our interaction, not only with robots, but with AI in general, and this probably says something not only about how we design robots, but about the human nature. So when we are in need, we tend to seek for help, even if we are not sure that the resource is super reliable, right? So it's like kind of exploration, etc. So what I'm trying to say with this, especially with the last finding, is that when we design for, at least from my experience, when I design for human-robot interaction, it's not only about the affordances that we put in our design, right? So how we design the robot in terms of appearance, behaviors, etc. But also we need to consider the human nature. Some characteristics that we, especially when it comes to trust, for example, some or anthropomorphization, etc. So there are some characteristics that are in our nature to exhibit when we interact with other people, and apparently also with some machines. So this was the first study. The second study has a totally different motivation and totally different approach, methodological approach. So as I mentioned in the beginning, I'm very much interested in understanding how we embed children's rights in human-robot interaction, in child-robot interaction. And this is not only about how we perform our ethical application, the ethical approval from our universities or institutions, but also how we as researchers and scientists are aware of these rights. For example, the people that are in human-robot interaction field, we know that probably, 90% of our sample, Severin knows better than me, of our sample are from developed countries with certain characteristics, right? So, and we hardly have studies that include, for example, children from Africa. So, with this study, this was my motivation to see, okay, how can we include children from developing countries? So this is with children in Uganda. In this process, not only because we want to develop systems that are fairer and non-discriminatory, but also because this is an opportunity for these children to be part of the dialogue that we have now about how to develop this kind of machines. Probably at some point they will use this kind of machines, right? So, but at that point, these machines will be developed only with children that have certain characteristics. So if we want to develop robots that are more inclusive, at least from my perspective, I felt the need that we need to bring other populations inside the process, right? Which was not something easy from multiple perspectives. I mean, it was like really challenging. And first of all, I questioned a lot myself because I collaborated with a school where you can see in the first picture, they lack the basics. And then it was like me going there and saying, okay, let's do some research with robots, for robots, So, and I was questioning myself a lot. I ran a lot of discussions. So I call this like cyber ethnography. So it took me months with discussions with the educators there, the people, the parents, etc., in order to understand first if I am allowed to do this kind of research, right? So would it make sense to this? And it was like a kind of Catholic response that I took from all the local people, that yes, we want to be part of it. We can't, we understand. So we never brought a robot there because it was like during COVID time. It is in our plans. But when I told them that, look, probably we are not going to bring a robot here, they told us, fine, it's fine, but still we want to be part of this research. So this was my motivation, and this was a qualitative research, what we call participatory action research, which means that it's not only participatory research in terms of how we design certain robots with the participation of children, but I involved them, their teacher as part of their team. And then it was like they were my co-authors as well. And what we did, here we tried to, I was very much interested in the cross-cultural aspects in terms of the understanding of the notion of fairness, because we talk about fairness in AI, for example, but we are not sure. Of course, there is research in psychology, for example, that says that fairness is very much related to the context, and there might be cultural aspects that plays a role in the perception of fairness. And I worked with this school in Uganda and the school in Japan, in Tokyo, in order to understand these differences. So we created a storytelling activity with certain iterations about fairness in different situations, etc. This paper was presented in a conference, Interaction Design and Children, which I really recommend for people that work with children. We got a small award also. And indeed, we found some differences between the two cultures in terms of the perception of fairness. in these two settings. But as I mentioned beforehand, for me, probably these results are really valuable, but for me it's much more valuable the process through which we went in order to bring in new populations in this research. So this was the second research, and the third study that I would like to present today is not related to robots. It might be, it has a potential. This is what I would like to do next. But this is a research on generative AI in education. And this was, while the two previous projects were initiated by me, my motivation. This was one of the projects that are quite common at the JRC where I work. So there is a policy need. So for example, last year we had this large the release of ChatGPT, and many people in education felt that, okay, we have this tool, all students use it, the teacher didn't know what to do, etc. So DGEAC, which is for education and culture, came to the JRC and they asked us to run a study on the use of large language models in secondary education. This is an ongoing study. I don't have results, but I would like just to present a little bit the methodology. The main research question here is, apart from understanding what are the current attitudes and perceptions of children, high school students and their educators for the use of generative AI in education, what is the impact on their critical thinking and problem-solving skills? So this is the main research question, and then we explored also the current practices. And this was a study with multiple steps because the topic, the topic was relatively new. Yeah. We also wanted to understand a little bit more how this tool has entered classrooms and schools all over Europe. And initially we ran some workshops with educators where we designed also some practical tasks. So they interacted with, we created an interface because we are very much interested in the data collection, but of the process, so the interaction with the model. Then we had pre-intervention questionnaires for students in order to understand their attitudes. Then the experimental intervention. I'm going to tell a little bit more here about the manipulation of what we call the AI tutor. Then post-intervention attitudes of the students, and then finally a workshop with educators where we tried to see how educators believe that probably the evaluation of students, high school students, should be rethought. In terms of the manipulation, again, this is not related. This doesn't include robots, but I'm very much interested in understanding how this would also be implemented with a robotic system. So we had three main conditions. In one condition, the system would provide the solution. So if the student, we designed different tasks, like in physics, in maths, writing an essay, a lot of tasks. And then the students, one group of students would interact with a tutor that if they get the question about the solution, the tutor would provide immediately the solution. In another way, in another condition, would provide the solution together with an explanation. And the third one, which is my favorite one, is the Socratic, which is the system doesn't provide the solution, but it starts with guiding questions. And through these questions, the children ideally comes to the solution. We have recruited 180 students from schools in Belgium and in Spain, and 60 educators. And the data that we collected, as I mentioned, was like survey, demographic data, their attitudes, current attitudes, etc. Logged data through the interaction, for the interaction. And then we ran post-intervention workshops. Also, we had anonymous material from these workshops. I don't have the results because we are still collecting data. We have done all the studies but one, so I don't. But anecdotally, I would say that the third condition, the Socratic, which is my favorite one, we observed in the workshops that this was the one that children hated the most. They didn't like it at all. This, of course, created many research questions for me immediately. So now I know my next study. I'm very curious about the results of the task performance in this way, but I'm not. I don't know if we will have significant results because this was just one session. So I'm very much interested in a longer term study where we would try this kind of tools and configurations with a longer term study. But I will come to this probably in a couple of months later. So these were like experimental studies or qualitative studies of different methodologies, etc., where I'm trying to understand the impact of robots or AI systems on children behavior and perceptions. And now I'm going to try to make the connection, right? So at the same time, while we run these experiments, I'm very much involved in different initiatives from international organizations that advocate for children's rights. So in 2018, I believe it was like, or 19, I was invited in that first meeting of UNICEF. UNICEF was the first organization that published what we call policy guidelines for AI and children. And as we had a discussion with, I think there were like 60 experts from 40 organizations, etc. We came up with a set of guidelines, and then what happened, it was that for different systems, I'm not going to go into details. This is published, so if you're interested, I can share links, etc. And what we were very much interested in, it was the piloting. So how we can make these guidelines, how to put them in an actual robot, and what would be the result of it, and what would be the process. So for this, we collaborated again with the Honda Research Institute in Tokyo. They provided the robot. This was like a 6 months or 8 months project, where in the upper line, you can see activities that it was like mainly from a human psychology perspective. So it was like me leading these activities, while at the same time, people from the Honda Research Institute were leading other activities. But often we were meeting together, and we were trying to make sense of the developments, etc. And we had many tests, and here, the study of with the children in Uganda would play also a role in terms of inclusion. We had other studies in terms of explainability, transparency of the systems, etc. We had co-design activities with children. This is about children's rights for participation, not only participation in the design, but also participation in our policy making decisions. And it attracted the attention of several other institutions. So apart from our publication with UNICEF, the IEEE Standards Association showed an interest in this, and we worked together in order to try to see how this would be translated possibly in the future into some standards. Lego Foundation also showed an interest, etc. So the Council of Europe, etc. With this knowledge, I went back to my institution and I told them, okay, we need also to write a report, because the European Commission is very fond of reports, right? So they really like to put things into something very well organized and coherent, etc. So I led this report where we tried to put together policymakers together with some experts and children. And what we observed, so we had several workshops, and what we observed, it was that although all these three groups talk about similar topics, about privacy, about safety, about explainability, etc., different groups give emphasis in different aspects, right? So, for example, policymakers from the European Commission gave a lot of attention to aspects like education, for example, where children gave more attention to explainability, etc. So, in human-robot interaction, especially for children, where we are now and what do we need for the future? Last year we conducted with some people from that are familiar with the community of HRI, know some of those people, like with Selma and Cynthia, etc. We ran a systematic literature review for research in HRI only published in the conference of HRI because we didn't have much time at the moment to do like a larger systematic review. And we tried to see how our current work in HRI, in child-robot interaction, corresponds to this UNICEF guideline. And we saw that there are some, just to mention that sometimes people do work with this, right, on these topics, like they do work on explainability, etc., but they don't put it in the frame of human rights, for example. So that doesn't mean that this is something new, of course, right? So there are many people in the community. And I didn't mention our study with Severan, for example. We did an amazing work with autistic children co-designing their robot, etc. So there are a lot of studies, but still there are some empty boxes there. So, for example, in terms of fairness, or explainability, we have many studies in terms of inclusion, but when it comes to inclusion, it's not about inclusion of such, so they usually mean inclusion of different kind of cognitive abilities of students, right? So, for example, autistic children and other populations, but not so much in inclusion from children from Africa, for example, other developing countries, etc. So, in this context, going back to the European Commission and the work that is done, probably you have heard about, some of you, about the AI Act. For those that haven't heard about this is the regulatory framework that is going to be implemented very soon in Europe about AI. And what policymakers have done is to come up with this pyramid, very simply. I'm doing a very oversimplified, probably, description here of this pyramid, who talks about AI that should be prohibited, or AI that is of high risk and should be regulated according to certain rules. AI that it is not a high risk, it's lower risk, but there we need transparency still for our system, and AI that with minimal risk. I just put this here for you in order also to, probably in a later discussion, to reflect on how this pyramid could be translated in our scenarios, in human-robot interaction and different scenarios, etc. This is something that it still needs to be elaborated. And lastly, this is my last slide, I believe. Yes. So with Virginia Dignum, who is one of the authors of the UNICEF policy guidelines, we sat down and we thought, okay, probably we need to come up with what it is called a regulatory sandbox. So this is like kind of process, and it is very well established in different fields, like in financial, for example, etc. There are also regulatory sandboxes for AI in Spain. They have done amazing work, but we haven't seen something specifically for children. And we, talking about the boxology that we had previously, so we came up with even more boxes for you. And this describes the process that we believe if we want to put children's rights in practice, we could consult this kind of procedures where we have transparency in terms of design, development, inclusion, etc. I'm not going to get into details about this. I'm happy to explain more if you want. It will be published. I think it's already online, open access, but it will be officially published in April 2024 as a book chapter. I put here a question myself. I mean, if nobody has any questions, so we have one here, about how we can ensure responsible design, development, deployment, and use of social robots that would promote children's rights, and possibly, and this is something that I'm very much interested in, responsible social transformation. And that's all. Thank you very much.
Hello, Vicky. Thank you very much for your talk. It was great. And I have some question regarding the study you presented about children from Uganda and children from Tokyo, which I think is extremely interesting for the reason you also enlightened. So we don't have any information about what happens when we bring HRI in other countries, not like the Western countries or Asian countries. And what we know by now is that with children from Asian countries, not only children, like all the population from Asian country, there is usually the collectivism culture that somehow can influence the way in which they are interacting with any social agent, so with a robot as well. But what about the African countries? What do you think that can be an hypothesis or an assumption about this? Thank you.
Thank you, Francesca, for the question. Very interesting question, and in fact, we were thinking, we reflect on our paper exactly about this. I didn't mention it here, but what happened here again? This is like kind of very qualitative research, and it's personal reflections. But when we had these discussions with children from Japan and from Africa, as you said, usually if we compare European and Asian, probably from Japan, for example, there are already studies, cross-cultural studies on this topic, and we identify as collective societies, the Asian ones. But here it was like, the Asian was like the individualistic ones, while we had the collective ones in Africa, right? So it was obvious how children, when talk about fairness in one country, we're talking about group fairness, while in the other country, we're talking about, in Japan, we were talking about individual aspects. So again, probably here I'm sure there are studies about these types of, relative, probably characterizations of different cultures.
Thank you. That's very interesting.
Thank you very much for the whole talk. I have one single question related to generative AI. The other parts are very interesting, but for the sake of time, what kind of generative AI system did you use for, or are you using for your experiment? And can you give us some details about an example, maybe, about what kind of process you engaged the students with? The process, I mean, what they were asked to learn. Now, the reason I'm asking this, it's because I would like to better understand how they felt during this interaction. And if you have trained, for example, the system on specific data related to the task at hand. We'll discuss later on about the reaction of the students. That's interesting.
Thank you for the question. So we developed an interface in order to be able to collect data ourselves, right? So first of all, I want to mention that this study, for this study, it took me 7 months to get the ethical approval from the European Commission. When I went first to the ethical board and talked about this study, it was like me planning to put time bomb in the in the classroom. Then multiple iterations about the data protection, etc., etc. In the end, we got the ethical approval of the study. So that's why we are now collecting data. So it took us a lot of time in order to get the ethical approval. We used the OpenAI API. We connected to our interface. We didn't train the system with any specific data. But what we did, it was we designed the AI tutor, so we gave very specific configuration per condition. We evaluated ourselves, so we tried to understand how accurate it is according to the 3 conditions that we had, like giving only giving an answer or giving an explanation, or the Socratic method. So we evaluated among our research team that this is accurate. We didn't train the students at all either, not the system, not the students. So the students would come with their current knowledge about this. In terms of tasks, we took some standardized tasks from PISA. PISA is the OECD educational assessment platform. So these tasks have been already validated by OECD, and we collected some tasks from the PISA pool of tasks. One was on mathematics, and another one was on physics, estimation. We were very much interested in what we call estimation bias. So if, so for example, we had like a large jar with coins, like a picture there, and we asked this, we told the children about, we asked the children to make an estimation, and then they would ask the confirmation from the system. Then the system would give the confirmation in these 3 different configurations, and then we ask the students if they would trust or not the system, that it is correct or not. So we had, I think, and the most interesting for me, especially for the critical thinking aspect, is the writing of an essay. So we ask the students to write an essay, small paragraph on the use of social media with teenagers, and then to use certain structure. So many of the children, we know that they just put the problem and copy paste it to the AI system, then they just copy and paste it to the answer. But we are very much interested in the process again, how this, I'm really curious, especially for the last one. In all tasks, we had questions before, immediately after the task, before we provide the AI tutor, the interaction with the large language model, if they are confident or the level of knowledge that they have on this specific task. And also we have a kind of baseline with their general school performance per person. So we wanted also to have a baseline there. So in principle, the procedure, it was only on their laptops, individual, and the procedure would go, they would go through different tasks, and we would ask about their confidence, their trust to the system, etc., pre and post the use of the AI tutor.
Still have time for more questions, and I forgot to say that yesterday. If you don't feel comfortable in English, please ask the question in whatever language, and we will do our best to translate it.
I will connect to the other question. The children were aware about the fact that the AI can hallucinate.
Yes, they were aware of this because we had a workshop. They were not aware that they were split in groups with different AI tutors. And that was very interesting during the discussion afterwards. And because some children would say, oh, this is like absolutely no sense, it was not nicely developed, etc., where some others would say, oh, it was like very good, it gave me the answer, ta, 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 ta. So they were not aware about the conditions, but they were aware first that so we had kind of little training. So we told them that they should not put personal information, names, email addresses, etc. So all this personal information into the system for ethical reasons. Then that the system made up answers, right? So they were aware of this, and I think these two topics. So we were very explicit about.
And they trust anywhere the machine, even if.
These we don't know. I need to go to the data and see.
Okay.
But we have specific question per task on this. So I'm very curious. So we don't know. I don't know yet. I need to go to the data and see.
Another quick question.
Sure.
What about the development of academia curricula for children, like maybe primary or secondary school?
This we asked the educators. So we ran these workshops with educators, and the workshops were split into two main tasks. Apart from their interaction with the tool, because we wanted all of them to have a kind of feeling how this tool works, about the educational purposes, like curriculum, as you mentioned, and the evaluation. And educators worry very much about the educational purposes now, and about their job, how their job will evolve. And some of them, they told us, oh, it seems that in the end we are going just to train students how to interact with AI. This is not what we want to do, etc. So in principle, we saw that educators are a little bit reluctant when it comes to the use of the tool by the students. They are not reluctant for the use of the tool by themselves. So they would like to develop lesson plans, because it's like so fast. It's like amazing. They would like to assess the students, tasks, etc. with these tools. It's amazing. We gain time, etc. So we have this. And then when we asked the students, they told us, yeah, we want to use it all the time because it's like so fast. We can get explanations, etc., etc. And we asked them, would you be happy if your educators would use it to evaluate it? And no, not our educator. So I already have a title of my next paper in my mind about this, how they would like, both groups, they would like to use it themselves, but not for the other group to use it, which is like super interesting for me.
Thank you very much for your presentation. It was very interesting because you mentioned so many themes, that you also worked with autistic children. You've also worked on the impact of different culture, the cultural diversity on your findings. So could you please, I know you have answered her question about the work you've done in Uganda, but could you please elaborate a bit more on your findings regarding this project?
Yeah. So first of all, this was not an experimental study, right? So the sample was very small. We had 20 kids in Uganda, one class, right, school class, 20 kids in Uganda and 20 kids in Japan. So I am not going to make any claim here, right? So I ran this study first because I was very curious, and I'm still. So this is like a kind of ongoing project. The teachers. I tried not to ask too many things by the teachers, but it's like a kind of voluntary. So there is no funding for this project. It's just an interaction with them, and for me, it's like I'm trying to understand the culture, right, and the differences, etc. So I am not going to make any claim about the findings. But what I'm trying to say, and that's why I put it in this presentation today, is that sometimes when we design robots, we really need to understand our population. And it is, I believe personally, that I am with a psychology background, right, educational psychology background. And I'm trying to understand what Mark or Severin would say about their robotics, cognitive architecture, etc. My point here is that also, it's very useful to have the other way around, also for you people that you work on technical aspects. It's good to have this understanding of the population or of the setting, etc. I'm not saying, I'm not an expert at all in robotics. I don't know how to code apart from now, right? So, but a basic understanding of the culture, the population, etc. I think it's really important.
Yeah, thanks. I completely agree. Actually, I have a computer science background myself. I'm an educator currently. I've worked in India with very small children who are like 3 to 5, but also like 5 to 13. And so I was just because so my part was computer science education, but for climate activism. So with the children, and so yeah, I worked with them for 3 months. So yeah, it's like whatever you're saying, like I can understand, because I worked with a rural population of children in India, and so it's very different from the urban population, because they're very much used to, well, everyone's used to screens these days, at least in India, even the kids. But even the way they think about things, the kinds of examples that are relatable to them, I mean, it's very different. So yeah, it's very interesting. And also, have you considered having an experiment like between populations? So like there might be some children who still, like in France, I know there are kids who don't have access to computers even now. There are some of them not at home. And so would it be interesting, I don't know, in Europe, to have a study between children who are in urban areas versus rural areas? Would it still be relevant?
Absolutely, absolutely. I mean, I would love to see such a study in the field. I'm very much curious. Probably you have heard about some countries in Europe that they have banned screens from schools. One of these is the Netherlands, where my kids are. So from last January, there is no screen at schools at all, like in the whole country. And Sweden does the same, if I remember correctly, and a couple of other countries. So for me, I'm not going to run this study, but I would love to see a study that collects data now, that this like super new, in 6 months and in 1 year from now, and to see the development. But I hope someone has already thought about this. Yeah. But you're right. Let's talk later. Probably.
Yeah, sure. Yeah, I'd
would
love to
hear more
chat.
about
Yeah,
your
thank
research.
you. Yeah.
So we have 2 last questions here and there.
So thank you very much for your presentation. And I would like to ask, if I understood it correctly, you did all the studies in a school environment. And what would you think about implementing this even to the preschool educational environment, like kindergarten?
I have done my PhD with children in kindergarten, not with robots, though.
Mm-hmm.
Very, very useful, right? So it's absolutely, but there are more constraints there in terms of, I mean, large cognitive variability, which is good, right? So I would love to see such a study. I hope I can do in the future again. But yeah, for several reasons, now I'm focusing on what we call K-12, right? So from 6 to 18 years old. Are you working on this age group?
I currently am working on a project where I design a kindergarten for kids with special needs according to the affordance and the material engagement theory. And I implemented, but now I'm concerned because of the ethics and stuff, but I implemented robotic toys into the classroom to like help the educational process. So yes, so this is basically why I'm asking, because
yeah, let's talk later.
Okay.
I would love to hear more about.
Thank you very much.
Hi. So I'm interested in the statistical aspect and the A/B testing of your experiments. So I know like it's really hard to get a lot of data from children. Like in one experiment you had like 20 children, in another I think 100, not sure. But my question is, have you maybe analyzed what would be a sample size of children required to get a significant result in order to like reject your null hypothesis?
Yeah, thank you, Vladimir, for this question. So in the field of human-robot interaction, we have certain constraints. I'm fully aware of the sample size. So if we, go and try to publish in psychology journals, probably this sample is really. I mean, the second study was the first study was 84 children, even not 100, right? So from psychology journal and the psychology discipline, this means nothing, right? So, however, in the field of human-robot interaction, although there are some large-scale studies, these are very rare, and we all know why. I mean, it's super expensive for multiple reasons, to run such studies. So I think the field, I mean, including myself, but also widely the field, is very aware of this. And there are actions, I mean, the last 5 years, I think, for reproducibility of this. So I think the field really needs to find a way to run probably the same study in multiple locations from different fields, etc., in order to achieve what you are exactly saying. So thank you for the observation. I think the field is super aware of this. Probably Severin can tell more about this because he's, I think, one of the people that pushes towards that direction. But we all know that it is super difficult to run large-scale studies. So, and that's why, I mean, very briefly, when I was asked to run this study with the generative AI, one laptop per child, etc., it was like super easy for me. So now I can run it everywhere, without and have like a really large sample. So as a researcher of human-robot interaction, I'm used in these difficulties, especially when you go to a school and you put your laboratory inside the school with all these, restrictions, etc. So, yeah, I hope one day we can make it better. Yeah.
All right. Thanks, Vicky. I don't know if we answered your question, but at least we discussed many other questions.
Exactly, later.
So let's thank Vicky again for her talk. Yeah. So what you are going to hear now is a talk on how did we do that in practice during the Spring project. So yesterday you saw the demo running around. Maybe you didn't see the huge machine that was here doing all the computations. And that's actually what Cyril is going to discuss, all what is around in practice so that we can run the experiments in the Broca Hospital. Cyril is the CEO of SoRAIM Automatisme, and this is a service robotics company. It's a second industrial partner in Spring, and they are in charge on assuring that the experiments run well, which is very easy to say, but it's very difficult to make it happen. So thanks, Cyril.
Thank you, Xavier. So hello, everybody. So I'm Cyril Liotard, I'm the CEO of a company called SoRAIM Automatisme. We're in the south of France, close to Marseille. And for the small history, we have been working with humanoid robotics for 13 years now. We started with Aldebaran in 2010 with Now Robots. I think we sold maybe a few hundred robots, mainly for robotic training, so which was the first purpose of Now. But then in the middle of around 2015, we developed some specific content dedicated to the usage of Now and Paper with children for education. So the way we'll call it is Now as a companion assistant, education assistant, and health companion. So we have a software suite which is called My Friend Now, where we have a lot of applications and games that are used with autistic children and I would say general education also. And the interest that we have in Spring is that for 15 years, we saw a lot of people, we have seen a lot of people in front of robots with a lot of enthusiasm before arriving in front of the robot, starting to speak, to move, to say hello, etc., and then having kind of dumb and idiot robot in front of them. So it's a bit frustrating. So the way we have been working for now is just having a kind of controlled applications for interactions with kids in particular. But we look forward to being able to do more and to provide more fun and activities for the children. So basically, in the Spring project, so we are the kind of integration geeks doing the the low-level work with the help of PAL in order to integrate the algorithm from the researchers. So today I will explain what is behind the scene So the scene is a robot in front of old people in Broca Hospital. But then it was a long pass before arriving to put the robot in front of those people. And there is a lot of hardware and software bricks behind that. So I will try to give you some insights about it. Okay, so the idea of Spring, I won't spend some time about that. You know that. So we put robots in front of old people and try to get as good as possible experiments or interactions between them. So you know the labs, you know the place at PHP. So PAD is the hardware provider, and the RM is doing the software integration. Okay. So basically, on our side, there were two objectives. The first one is to provide a hardware and software environment which allows running the experiments with the Broca team, with odd people. So there were several constraints about that. That we need a lot of computing power, much more that is available on ARI today. We must use web services also for the dialogue. So with the Scottish data language module, we need to generate and handle a very large amount of data, like plenty and plenty of gigabytes of video, audio, and so on. And the last but not the least, we cannot use the network of the hospital because of safety concerns and security concerns. On the second end, in terms of objectives, we have a team in Broca of people who are not experts in IT and programming robots and development. So the idea is to provide them with I would say an autonomous tool, autonomous robot, so that they could run the experiments without calling us every hour or every day to get some answers and to understand what happens. And on the other side, we generated a lot of data, but we need to deal with that data to anonymize them, and also in that side, PHP needed some, I would say, custom tools in order to work on the recorded data and be able to share them in respect of the GDPR. Okay, on the hardware, so we go to this. So basically, that's what we have today. So the center of the experiment is the ARI robot with the patients. As I said, the computing power of ARI is good, but very limited regarding what we want him to do. So basically, we added a kind of external server on which the algorithm run. It's very, I don't have all the specs in mind, but I think it's 32 gigabytes of RAM server, something that we paid like 15,000 euros with high power graphic cards from NVIDIA. So yeah, something very powerful. Then we also put a server NAS in order to handle the big amount of data that we generated. Everything is on the Wi-Fi network inside the lab of the hospital. Really connected to the Wi-Fi network, we have a 4G router that will handle that will be the gateway to the dialogue server, which is based in Scotland, in Edinburgh. So that's the way we use the dialogue server service. And then for the experimenter, we developed a tablet application, which allows the experimenter to run the application, monitor it, to see the alarms, etc., and also to control the interactions with the patients. Okay. So basically, that's what I said. So this experimenter's interface. So this is I would say a web module that we developed on Android. So it runs. There are two parts: the interface, experimenter interface, which runs on a tablet, We will control the launching and stopping of the different modules in order to run the experiments. We can start the dialogues, choose the type of interactions, and we also have a monitoring of what happens inside. So if everything runs well on the modules, if there are some alarms, some problems, we can record the status at any time on what happens. So this service on the tablet for the experimenter is connected to a server on the big one, on the big server, where we gather all the data. And then we can perform statistics. We monitor the diagnostic alarms, the activity, the connection, etc., etc. So this is what is used by the team in Broca in order to run the experiments and gather and collect the data. Then we had also to develop a recording feature. So that was at the very beginning of the project, before before we had the first level of software. The idea in Spring was to make an initial data collection. So starting to gather data, just to be able to train the algorithm before putting them on the robots. So that was our first part of the project, develop a data collection module. So recording videos, audios, etc. So that runs as a service. That runs as a service on the server. It's controlled by the tablet, and then basically we get everything from the robot, putting that on the server without using the CPU of the robot. Okay. So everything is recorded in the NAS server, and then we have a second part of software to be able to handle this recorded data. Okay. Yeah. One other thing is that we worked. So that was a small part of our job, working on the eyes in particular. The beginning of the project, we had kind of still eyes. So yeah, not really human, I would say. So we developed a little module to have lifelike eyes with micro movements, aesthetics, eyelid correction, and so on. So it allowed improving the patient experience with the robot. And then also on every there is the screen, or the chest screen. So we had some discussions among Spring to see what we could do with that screen. The idea, or the conclusion at the end, is that we will use that to make a kind of dialogue transcription of the conversation between the robot and the patient, so that the patient could see where they stand in terms of inside the discussion, and that would also help the comprehension and accessibility. Okay, and then in the background, so we have different softwares also. So the first one is the startup and the diagnostic screen. So this is used by the experimenters. It allows them to run to start the different modules, to get also the log of the different modules to see what happens. So in each modules there were some ROS messages. Saying what happens if there are some problems on the modules, on the running of the modules. So everything is gathered, and we have a lot of diagnostic informations, maybe too much, and at some point we will have to put some filters about that. But it allows to see what happens on the robot. Then the data collection. So that's the interface we developed at the beginning on the first phase. It's a kind of Wizard of Oz. We used a kind of puppet approach on the robot to generate some basic behaviors on the robot, and be able to start an interaction between the robot and the patient, and recording everything. So that was used in the first year, on the first 16 months, before we had the first version of the full software. And then different utilities, monitoring, reading, encoding, displaying, that we added in the different and the current versions. And of course, a lot of documentation, working on the data management, the startup procedures, installation, the API of communication on ROS, and some support. So we spent a few weeks in Broca to do some integration work between the labs, PAL, ERM, and Broca. I think maybe 3 weeks we did or something like that. And now, so we had different runs of experiments, and I think since October there has been a continuous experiments at the hospital. So, but Xavier will tell you about that later, I guess. Okay, that's it for the low-level robotic integration.
So we have time for some questions for Cyril.
Thank you. What do you think? How specific is it to this project, and how much of this is actually something that you are happy to, I don't know if you had already released it or can be reused for other projects? What do you say is the sort of the coolest tool that people want to reuse, and what is just so specific to this project that I shouldn't bother?
Today, and maybe Xavier and Severin can share about that, but the main blocking point is the hardware performance we have, because the way we built the ROS architecture with the different algorithm and the high computing power needed, this is not compatible with an embedded hardware platform in a robot in ARI. So we see that there are some optimization work to perform on the code, and maybe some more power also to put in hardware in the next years. But if you tell me, okay, what will you be able to deploy in 2024, 2025? Yeah, it's not easy, because we are probably 2 years or 3 years away from getting parts of the code embedded in real life robots.
Yeah, no, because I see that every project basically just sort of reinvent the wheel for these sort of tools, right?
Yep.
So that's why I was wondering if there's a more principled solution that we could adopt as a community.
But maybe Severin, you want to discuss about the HRI module that you will you stabilized in Spring?
I mean, I agree with you. It's very frustrating because it seems that we are always reinventing things. I do think that maybe what I was calling the glue this morning is a progress in the right direction, where we are going to be able to reuse a lot of the modules, because we kind of did that job of setting interfaces that would actually become standards in the ROS ecosystem. So those modules that belong to this ROS for HRI world, they are not stuck into the Spring robot for the Spring project. So that is one thing. But now Thierry is completely right to say that, you remember those beautiful boxes this morning? I said there was 52 of them. I think out of those 50, there's maybe 10, something like that do require a state-of-the-art GPU to run. So you need to have basically 10 state-of-the-art GPU to run together. So that's why we end up with a base station that costs indeed 15,000 euros, because we need like a kind of a really high-end GPU there to be able to run things. It was kind of okay to do that in a research project, saying like if we stick to what we have on the robot, then there's a lot of really cool algorithms that we are going to talk about in the coming days that would not exist, and that's the whole point of a research project, is to kind of push the envelope of what we can do. But that also means that, unfortunately, and I don't know if I'm allowed to say that, but there is not much from the Spring project that will become a product on ARI tomorrow, because we don't have the resources today on our platform to do that. So in that sense, we are going to reinvent that next time to have something more optimized, more like faster, and so on.
So if I may add to that, I think so there is one thing that makes this very difficult, is that these 10 boxes that you are saying, each of them is a different expertise. So it's not even the same partner and the same person that actually produced that box. So if you wanna, like, let's say, optimize it to something, like you need that expertise and to discuss with that person, right? So that's one thing. Another thing is that all these like GPU-based modules Of course, the models can be quantized, can be reduced, trimmed down, distilled, blah, 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 blah. But there is not an automatic way of doing that. So this is yet another difficulty in there, right?
So that's a very, very good point. And actually, we are in our company, we are now trying to set the stage to have a couple, like probably two, or hopefully not more than two, maybe three backbones that will be with different heads for specific tasks, to be able to kind of pull together all the heavy duty part of like getting the cameras down to embeddings. And then what we do with those embeddings can be a much lighter piece of code. So that's not going to solve the problem of we need an extremely focused expertise in, I don't know, audio processing, in LLMs, in face tracking, things like that, to be able to optimize the models. But it's also true that the incredible power of backbones makes it possible to probably group some of those functionalities together and have only to optimize the heads, the final layers of those architectures. So we are moving in that direction.
Yeah. They're going to end up in the camera anyway. Near future. Yes. In the camera, embedded device that does that.
Thanks. Actually, your comment, Mark, is leading to my question. The question is addressed to the three of you, actually. How much robust is the robot itself in its interaction with people, and does it depend on the fact that the whole network has to be up and running at all times?
So yes.
That was the answer. Yeah, it's not robust at all. That's I mean, because of all the things you say. No, it's a very complex architecture that needs everything to be running perfectly, not perfectly, but yeah, very well. So yeah, we are not. It's big weak on robustness at this point. We hopefully will be better by the end, but yeah.
And something important is that I think we had like maybe 15 or 20 people programming, everyone with its own approach. So we benefited from the ROS architecture, but still it's a lot of different people working with different methods. And at the end, we didn't do a kind of overall reviewing of the code and optimization. So probably it also explains some instability we may have. And in real life, if we would have liked to put the robot on the field for real, this work would have been needed and would have taken a lot of time.
Hi, I have a quick question. Thank you so much for your presentation. I was curious about the dialogue server, HUW cloud. Could you tell a little bit more on the backbone behind the dialogue server? Like, what are the components?
Yep. So Daniel, maybe you want to answer this one.
There will be a specific presentation on that, I think. They ask about the server at Harriet One, but you're going to discuss this specifically tomorrow, right? Yes. So you will get
okay, so then you have to wait tomorrow.
Is there any other question? All right, so I guess that concludes the session. So let's thank Cyril and Vicky again.